All right, this is chapter 9 review. I'm on page 612. I'm going to be using my identity sheet. All right, so starting at number 21, it says the sine of alpha is 4/5, and it tells me what quadrant it's in. It's in quadrant 2. All right, so that's 4/5. That's a 3, 4, 5. And it says the tan of beta is 7/24. So that's a Pythagorean triplet too. And it tells me it's in quadrant 3. So it's opposite over adjacent, and that's 25. All right, so we're just using the sum and difference. I'm just writing A for alpha. All right, so it's just the sum and difference. The cosine sum is sine beta cosine alpha plus cosine beta sine alpha. All right, and then you just substitute the numbers in. Sine beta cosine alpha plus is plus, and then we do cosine beta sine alpha. All right, I had to draw the triangles so that I would know. All right, so this is, I better write this down here. All right, so the sine of beta is 7/25. You could probably do this by now. Cosine of A is 3/5. You're just going to do the math. Cosine beta is 24/25. Sine of alpha is 4/5. I'm just going to write the answer. This is 21. You must come up with -3/5. All right, the tan of beta, I'm going to do last because I'm going to do this over the cosine. Oh, wait, they did this. I don't like the way that they did this. I want to do cosine. All right, we're gonna have to do the tangent. If they would have said sine of beta plus alpha, cosine beta plus alpha, tan of beta plus alpha, then we could have done sine over cosine. But of course they didn't do that in this problem. All right, so the tan of beta is just from it's I'm gonna run out of room. It's the tan of beta, so minus is minus tan of alpha over 1 plus, then multiplied. Tan of beta, tan of alpha. You can substitute those numbers in here, all right? Cosine alpha minus cosine, so minus is plus, and it's cosine minus is plus, and it's cosine alpha cosine beta plus sine alpha sine beta. I'll just tell you what the answer is because you could do this math. This is algebra, right? Substitution. So for B, you get 117 over 44. And for C, 44 over 125. I hope I'm looking at the right answer. Yes, 21. All right, 23. I'm glad they use Pythagorean triplets. All right, so for 23, it says the sine of x is -12/13. It tells me which quadrant. It's in quadrant 3. the secant of y. That's the inverse of the cosine. So it's going to give me hypotenuse over adjacent. All right. Make sure I'm on the right problem. Secant of y is 13 over 12. What quadrant is it in? It's in quadrant 4. Quadrant 4. All right, so I'm going to draw. And what does it want to know? Find cosine of x plus y. Well, that's cosine of x, cosine y, minus sine x, sine y. All right, we have sine x, negative 12/13. Let's draw this one. All right, so it's negative 12/13, so it's 5. This is x. So we need cosine of x, which is, it's gonna be negative because it's in quadrant 3. That's a negative 5/13. Now let's draw y is in quadrant 4. We have the hypotenuse over the adjacent. So this is negative 5. All right. So the cosine y is 12/13. The sine y is negative 5/13. When you multiply that out, I'm just going to write the answer, 23. It equals negative 120 over 169. All right, that's number 23. Now we're going to jump to 33 on the next page. All right, what is prove the identity? All right, 33. All right, 2 cosine x minus 2 cosine cubed x equals sine x sine 2x. I see two things I probably want to do. I want to factor out the 2 and a cosine. That's going to be 2 cosine x, because that's 1 minus a sine squared x. All right, so for this one, normally you work on one side, but I'm not. Oh. I don't think you can. I think you have to work on both sides for 33. All right, so I'm going to substitute. That's the double angle. So that's sine x, and that's for the double angle. It's 2 times sine x cosine x. All right, so let's just simplify this. 2 cosine x, 1 minus sine squared x equals 2 sine squared x cosine x. Does it say 33 is an identity? It does. Did I write it down? Oh, I don't know why I changed this. It's cosine. I don't know why I changed it. My brain just changed it. All right. Now, actually I didn't need to do this, because this 1 minus the cosine squared x almost looks like, but we're gonna keep it like this. All right, this, well, we're done, because this is actually the sine squared x. I'm there. This is 2 cosine x. For this, I'm going to substitute in sine squared x equals 2 sine squared x cosine x. All right, so what do I have to do? I factored on the left-hand side. I really didn't until I substituted here, but I obviously made that mistake. I used the double angle identity to prove it. All right, 43. All right, 43 is, this is 43, 5, tan of x equals 2, sine of 2x. I see the double angle. I probably want to write that in sine and cosine. It says find exact solutions. All right, so I'm going to say this is 5 sine x over cosine x. And this is the double angle. So it's 2 sine x cosine x. If I move everything to the left, I have 5 sine x cosine x minus 4 sine x cosine x equals 0. If I eliminate the denominator by multiplying everything by the cosine x, then I end up with 5 sine x minus 4 sine x cosine squared x equals 0. I can factor out the sine squared x. The sine x. Sine x, 5 minus 4 cosine squared x equals 0. I can set each term equal to 0. Sine x is 0. 5 minus 4 cosine squared x equals 0. What is this going to be? Cosine squared x equals negative 5 fourths square root cosine x. This is imaginary. Never mind. There's no solutions for that one. Just solutions for the other one where the sine x equals 0 because that's imaginary. So what is that? That's at, it equals 0 at 0. All right, that was 43. I'm glad I'm writing the numbers here. 45. Okay, 45 is, you have to really think outside the box. You might be thinking, I have to think outside the box on all of these. All right, 45. 2 cosine x plus sine x equals 0. The only thing I know I can do is, how can I make this look like the tangent? Because the tangent is sine over the cosine. So I'm going to subtract 2 cosine x from both sides. So I have sine x equals negative 2 cosine x. All right, now I'm going to divide by negative 2 cosine x so that this equals 1. All right, so then we have sine x over negative 2 cosine x is 1. Really, I could say this is negative 1/2 times, well, let's just multiply. Let's multiply by negative 2. I don't even have to. So I have the sine x over cosine x is negative 2, or the tan of x is negative 2. And then I can use inverse to solve for that. I don't think you can get an exact solution. This is 45. Yeah, it's a decimal. So you do inverse tan negative 2 in your calculator. It's going to be in that fourth quadrant. And you can solve from there.